So today we are going to solve a problem on Kriging. That practically that how if we have a scenario in which there are several points and we are going to calculate suppose grade value at an unknown point, given that we know its distances, the distances that they have from each other. uh, Kriging equations and Kriging setup, it is blue, it gives best linear unbiased estimation. The equations are I guess you will be familiar with. So anyways, let's come to the practical point. So if we have 3 points, say P1, P2 and P3, and we know the grade values and the distances, horizontal distances of these points. Say we have this point P1, it has x value or the distance 0. Suppose it is the origin, and then this second coordinate, it is for grade, which is denoted usually by say G or Z, whatever. Then we have this point 2 having horizontal distance of 10 units and grade of 14, while this is the point where we are going to estimate our grades, having a distance of 6 from this origin, and of course we are going to calculate its grade. So P1 at x0 with value z1 or grade at 10, or the quantity in which we are interested in order to find out for the unknown point. And then we have this point 2 at x distance is 10 units, value of z is 14. Suppose we have z is for grade, then our goal is to estimate the value at p0, which is over here, having x6, and we are going to compute its Kriging variance as well. So the mean and variance is how we are going to find that out. Point 1, the mean values x0, z, p2, the distance and the grades, then the sample mean. Mean is simple, z1 plus z2 divided by 2, as we have only 2 points. The third one is unknown, so we are not going to include it in this. And then we have the variance formula for sample variance, the n-1, and for population variance we take, instead of n-1, n. So it equals zi z, grade of the known points minus the mean from each and every point, and taking the squares, dividing it by n-1. How we are going to do it, we will see. So z1 minus mean, and then taking the square of this value, plus z2, grade of the second value, minus the mean, then taking square, and after that dividing it by n-1. How? So we have found out its mean, which is 12, and the sample variance is 8. So how we have calculated it? We have calculated it by z1 is 10 minus mean is 12, then taking square, plus z2 is 14 minus mean, then taking its square, whatever value we are going to get from it, then dividing it by 2 minus 1, which is 1. So 8 is the resultant. You can calculate it. Then we have the variogram model. We will have a variogram on the basis of which we are going to estimate the Kriging. So which model does it follow? For simplicity purpose, let's assume it follows 0.1 h. H is the distance. Okay, so there are other formulas in which we have the c0 plus 3 by 2 h by a plus or minus 1 by 5 h cube by a cube, and for the spherical and so on, but we are not going to dive into that. So anyways, the semi-variance of a value with itself, of a point with itself, the variance is 0. Between point 1 and point 2, it is 1. How? We will see it shortly. Then between point 1 and point 0, which is our interest point, it is 0.6, point 2 and point 0, it is 0.4. Then the ordinary Kriging linear system, we have the semi-variogram form. In matrix form, the point 1, point 1, point 1, point 2, and plus the constant lambda, you know the Kriging equations. So anyways, into W1, the weights matrix, basically it will be like this, you know, semivariance of point 1, 1. Then we have the second term, semivariance of point 1, 2. Then the constant of the lambda, which is 1. Then this matrix complete, and here we have the variance W1 weights. We have supposed over here only 2, W2, and the lambda. This is the second matrix, which equals to the variance of point 1 with the point of interest, which over here is 0, say, or P0, and the variance of point 2 with the point of interest. And in the Kriging system, you know, the weights, the sum of weights is equal to 1. So here we have 1. This is the other matrix. Okay, so this is in matrix form. Now putting the values of this variance, or let me make it further simple. Come over here. Instead of matrix, we will solve it using equations. You know, the Kriging equation is W1 semi-variogram of point 1, point 2, point 1, point 1 plus W2 gamma semi-variance point 1, point 2, and if we had 3 or 4 points, then W3 gamma point 1, point 3. If we had another point, then W4 gamma point 1, point 4, up to so on, and plus this lambda equals to gamma point 1, point 0. Similarly, another equation, as we have only 2 points, then we will have 2 equations of this form. Then W1 gamma point 2, point 1, W2 gamma point 2, point 2. If we had another point, plus W3 gamma point 2, point 3. If we had another point, plus W4 gamma point 2, point 4, up to so on, plus lambda equals to gamma of point 2, point 0. And another equation, as we have only 2 points over here which are known to us, so we will have 2 equations. So W1 plus W2 equals to 1. Okay, this is the equation. That is why we say it gives us best linear unbiased estimation, because we have taken all the weights equals to 1. So now this is an equation form. So the variance of a point with itself is always 0. So W1 into 0. Similarly, W2 variance 0.1, 0.2 plus lambda gamma 0.1, 0.0. Then we have W1 gamma 0.2, 0.1, which is over here, plus W2 gamma 0.2, 0.2, it's again 0, The variance between point 2, will be 0, point 3 would be 0, point 4 would be 0 if we had multiple points. So is the same. You know what I am trying to do is that you guys get the basic concept of how we do it. Then W1 plus W2 equals to 1. If we had 4 points, then W1 plus W2 plus W3 plus W4 would have been equal to 4. Anyways, so the basic equation that we have assumed, the semi-variance is equal to 0.1 h. Instead of going into complexities like C0 plus 3 by 2 h by a into half h cube over a cube and so on. No, we are going to make it simple. Variance formula is semi-variance is equal to 0.1 h. H is the distance. So between point 1 and point 2 the distance is 10. So the variance between point 2 point 1 would be 0.1 h. 0.1 into h into 10, we will get 1. Similarly between point 1 and point 0 the distance is 6. Point 1 and point 0 the distance is 6. Look here, it's origin, so 0, and here 6 units. So the distance between these two is 6 units. Okay, so putting it into the equation, 0.1 into, instead of h, 6, 0.1 into 6 equals to 0.6. Similarly the distance between point 2 and point 0 is 4. How? You see, this is from origin at 6 units and this is at 10 units. So the distance between these two is how much? 4 units. So we have taken it and have calculated it. The variance between the 2 points is 0.1 into 4, which becomes 0.4. So then we had these equations. So we are going to put our values. This was 0, and point 1 and point 2 the distance was how much? 10. The variance was 1. Putting it, so W2 into 1. Similarly point 1 and point 2, or point 2 and point 1, the distance between these two is again same and the variance is also same. Then again, then the variance between point 2 and point 2 was 0 plus lambda is equal to 0.4. We have calculated it. And the third one, as it is, W1 plus W2 is equal to 1. So suppose we write it in terms of W1. W1 equals to 1 minus W2 if we shift it to the other side. So putting it in equation 5, which is over here, so what we will get? We will get 1 minus W2 instead of W1 plus 0 plus lambda plus 0.4 as it is. So now we have this equation, which is equation 6, and we add it with this equation, which is equation number 4. Okay, what we will get? We will get W2 and minus W2 will get cancelled. So we will get 1 plus lambda and lambda over here and lambda over here. We will get 2 lambda, and on the other side we will get 0.6 and 0.4. 0.6 and 0.4 we will get 1. So 1 minus 1 is equal to 0, and lambda 2 lambda will be equal to 0, lambda equal to 0. Okay, so now we will put this value of lambda, which is 0, in equation number, say, 4. So which implies equation 4 is over here. 0 plus W2 plus lambda is equal to 0.6. So which means W2 is equal to 0.6. W2 equals to 0.6. Okay, we have found one weight. Then for the other, as we have only two weights over here, so W1 plus W2 is equal to 1. Putting the values of W2, so we will get W1 0.4 and W2 0.6. Now we have got these weights. How we estimate the tonnage or grade? How we are going to estimate the grade of the unknown point? If we have only 2 points and the grades of those two was known already, then we found the weights W1 and W2. These are the Kriging weights. Putting the values of W1, which is 0.4, and the grade, which is 10 of the 0.1, so 0.4 into 10, plus W2, 0.6 into Z2, which is 14, you will get 12.4. This is the estimated grade at our unknown point, which is over here. Okay, we have calculated it that the grade over here is 12. Okay, that the grade over here is 12.4. So how we are going to find out the variance of estimation? So the variance of estimation, its formula is sigma square equals to W1 steric gamma 1 and the point of interest, as we had only 2 points, plus W2 gamma 2 and point of interest. If we had another point, then it would have been plus W3 gamma 3 into point of interest, and so on, and plus the lambda, or we have written it over here, but it should have been lambda, so let me make it lambda. At times we use it mu for mean. Okay, which equals to 0.48. Okay, so this is the Kriging variance, and we have calculated the grade. So let's come back to the how we are going to find it using matrix equation. You know, this can be changed into matrix equation as well. You know, if we had multiple equations, we would have used it like in the matrix form, like this. W1, you see, this would have been the first term over here, this would have been the first term. Okay, then space, this would have been the third term, second, sorry, and the third, its coefficient would have been 1. Similarly, gamma p2 p1, gamma p2 p2, and lambda coefficient 1. Then here we would have W1 1 plus W2 again 1. There is no third term, it would have been 0. Okay, this would have been the first matrix. Then the third matrix would have been W1, W2, and the third term would have been lambda. Okay, equals to, this would have been the first point, this would have been the second point, and the third would have been 1. Okay, so again, using the matrix multiplication, we would have arrived at the same points over here, W1 gamma P1 P1. So it's interchangeable and can be easily solved. So this is an example of how we are going to find the estimated grade and find its variance if we have, say, 2 points having known values and a third point which is our point of interest. So similarly, it can be used for multiple points, but the basic concept would remain the same. Okay, thanks.